All right, so let's do this. I'm not even going to change the numbers. I don't even think I need to. Or I'm going to call on anybody. Good start. Good start. Good start. This is why. Because you screwed around with it. All right, now we can maybe start. All right. If it goes off again, I'm just coming full speed and spearing you right out of your chair. So heads up, if this goes down again. All right. Just warning you too, Nyla, because you might want to get out of the way. I know you need your arms and hands for later. All right, so let's do this. Here's why today I think is a little bit more difficult than yesterday. Yesterday, you did not even need to worry if the units matched or not. You didn't need to, because they always did. Now we have to pay attention to it. Start reading this problem here. I got a tabletop. 43 pounds per cubic inch. Stop. What's the 43? Density. Good. We learned that from yesterday. 43 is my density. But here's the issue. This is for one of you. Mr. Culligan. No, that's all right. Yep, already left. Yep, no problem. Come back. All right. Anybody else? We're good? Sorry to interrupt here for the third time. Density, 43 pounds per cubic foot. Per what? Cubic foot. Keep reading. Look at those dimensions. Anybody see an issue? Oh, 8 feet for the length, 3 feet for the width, and then what about for the thickness? That's a problem. We can't do anything. Do not try to find the volume until all the units match the density. And I will tell you why. Everyone knows this classic conversion, right? 12 inches equals a foot. What's volume in? What type of units? Cubic, right? Well, I hate to break it to you, but if you try to convert after you find the volume, this is not a true fact. Those are not equal. I am not offering, I'm telling. We need to convert units before we find volume. All right? So I need to take that 1 inch and convert it into feet before I find the volume of that tabletop. All right, how can I convert? If you don't know what to do with the 12, multiply or divide. I've been doing it since unit 11. Set up a proportion. 12 inches equals 1 foot. I have 1 inch, so that's going to go under the 12 inches. How many feet would that be? And please leave your answers as fractions. I don't like decimals written in here. So 1 inch will be how many feet? Just 1/12 of a foot? Right? That's 1/12 of a foot. If you cross multiply, you get 12x. Divide both sides by 12. All right, now they're all in the same units. Now we can calculate the weight of the tabletop by using our density formula from yesterday. Mass divided by volume. So I have 43 was the density. Mass is what we're trying to find. Volume you now are allowed to calculate. But again, we don't calculate volume until all the units in the object match the density units. So what do we have here? 8 times 3 times a 12th. Not 1, but a 12th. Convert it now. So the volume of the tabletop, 2 cubic feet. Whew. Plug it back in, 2. Let's cross multiply. This tabletop away. 86. Anybody know, even though I don't require it? How can I find what units this is? It's in the density per pounds per cubic feet. So 86 pounds. Whew. We're all right. Got to pay attention to the units now. All right. You can't just fly by that. Do my density and object units match? If they don't, change them now. Change them now. All right, moving on. This has nothing to do with density, but has everything to do with converting units, so that's why it's here. And also, could be a word problem type on Friday, because they're not all density. This would be what I call a volume word problem. There's 3 of those on Friday. All right, so we got 2 concrete slabs that are exactly the same, and they charge us $3.25 per cubic foot to put the concrete down. How much is it going to cost us? $3.25 per cubic foot. Anybody notice anything with the diagram? It's so don't calculate the volume in inches. It's not going to do us any good, and you can't convert afterwards. Do it now. So take your 36, 36, and 4 inches and convert those bad boys to feet, because that's what they're going to charge me in, feet. $36 inches. What do you got? How many feet? 3 feet. 3 feet. And then how about that 4 inches? 1/3 of a foot. Yep. So 1/3 of a foot. And also, because this was our old Regents question, how do I know I'm doing volume? How do you know it's not surface area? Because they're charging me per cubic foot, and any time we hear the cubic, that's volume, correct? So let's do this. The volume is going to be, let's see now, 3 by 3 by 1/3. So I have 3 cubic feet. Ooh, a little sneaky though. Why is this sneaky? Yeah, I have 2 concrete sections I'm throwing down. All right, so times 2, I'm actually going to get charged for 6 cubic feet. All right, how much are they going to charge you now? You know, it's $3.25 for every cubic foot. $19.50. So that's what I would consider, if you guys hear me talk about Friday's test, that's what I consider a volume word problem. All right, it had nothing to do with density. The next one is a density problem. Buckle up. Socks might get knocked off. There's tissues in the back if anybody just can't handle this one. Snow cone. All right, so I got a hemisphere on top and a cone on the bottom. Perfect. You see, I've given you the density. You don't even have to worry about if that's density or not. I'm telling you it is. They charge me $3.83 per kilogram. All right, how much is it going to cost for the ice for 50 snow cones? Wow. All right, my first question, do I need to convert any units? The density is in centimeters, right? And what's your cone in? All right, we're good. So we're done. We don't need to convert anything. All right, so we can find the volume at least. Because they're going to charge me for the mass of it. So D equals M over V. Density, 0.697. Mass over, all right, I need your help now. What's the volume of this snow cone? Hemisphere. 4/3 pi r cubed, but that's a sphere. I need a hemisphere. Plus the cone that the hemisphere sits on, 1/3. And again, this is all off your formula sheet, so no reason to ask you guys. Pi r squared times the height. Just make sure you're not plugging in 8.3 because that's the diameter. All right, find your volume. non-rounded volume. Whew, a lot of typing I hear. $333 and change. All right, so I go back to density, plug that in, cross multiply, and that will give you the mass of one cone. Before I move on, know what units you're in. This is what, 232.55. Look back at your density. Grams, right? Because the density was in grams, so when you find the mass, it'll be in grams. But the problem is, this is why it might be a little bit of a tougher problem, they charge $383 per kilogram. Okay, so I don't want to multiply by 383 here. I need to change this into kilograms before I apply the money. I told you if it's not on your formula sheet, I'll provide it, and that is the case here. Anybody know? 1 kilogram showing off. Look at you guys, 1,000 grams. Yep. So are we okay? I got to convert this to kilograms because that's how much they're charging me $3. What they're charging me $3.83 for. All right. If you don't know what to do with the 1,000 grams, ready? Rewrite the conversion you've been given and make a proportion out of it. Put the grams under grams and solve for kilograms. So that's what one cone is right up here in kilograms. All right, what's your next move? Because there's a couple, if you want to apply the $3.83 now, go ahead. But how many cones you doing it for? 50, right? So I just want to make a quick point before you finish this problem on your own. I could have multiplied by 50 up here when I found the grams. I can multiply by 50 right now. Or if you want to do it after you multiply by $3.83, you can do that too. Because remember, multiplication doesn't matter order, right? Order doesn't matter in multiplication. So you could have applied the 50 at any time after you found the mass. So multiply by 50 now, multiply by $3.83, it won't matter. $44.53. All good? Okay, here's where we're going from here now. I'm done. All right. It's been real. It's been good. Hasn't been real good. You're going to call me over when you finish a problem. All right, and then I'll give you the okay to proceed. Number 4, you're going to need a conversion. Before you start, you're going to need a conversion. 1 meter equals 100 centimeters. All right, I don't believe that's on your formula sheet, so that's what you need to convert it into. 1 meter equals 100 centimeters. Again, you want to work within your group, feel free. But I also know some of you guys like to speed up and do it individually. I still need to see it, whether it's in your group or individually, before I let you go on. All right, because these are some tough problems. Are we ready to roll, ladies? You ready to go? They're going to keep working. The floor is yours back there. You can do rock, paper, scissors, 2 out of 3. Who goes first?